Hi, now we'll continue the problems for thermodynamics chapter. First problem, calculate the change in internal energy of a block of copper of mass 200 gram when it is heated from 25 degrees Celsius to 75 degrees Celsius. Assume the change in volume is zero. Change in volume is zero here. Okay. The formula for heat energy, quantity of heat energy supplied to the body is mass into specific heat into difference in temperature. M into C into dt, that is equal to dq. So what we have to calculate now? du. First we'll calculate what is dq, then we'll go for du. Mass 200 gram, specific heat 0.1, change in temperature 75 minus 25. 75 degree minus 25 degree. We'll express in degree, then we'll change it. So 50 into 200 into 0.1 will be 1000 calories. We have to convert into joules. So this formula changes to 1000 into 4.2. 1 calorie is equal to 4.2 joules. So you will get 4.2 into 1000. That will be 4200 joules. By first law of thermodynamics, we know dq is equal to du plus dw. dq is equal to du plus dw. Okay. Here the question is volume change is zero. Work done for a thermodynamic system is P into dV. Volume change is zero means work done is zero. Therefore, dq is equal to du. So I can write 4200 joules. Straight problem. Okay. Right. Second one. Calculate the change in internal energy when 5 gram of air is heated from 0 degrees Celsius to 4 degrees Celsius at constant volume. CV is equal to 0.172 calories per gram per Celsius. Calculate the change in internal energy at constant volume. CV value is given 0.172. Formula for work done, you know, P into dV. Volume changes, volume change in volume is constant. So constant means P into dV becomes 0. Change in volume 0. So P dV 0. What you have to calculate here? Change in internal energy. Du you have to calculate here. So dQ is equal to mass into specific heat into difference in temperature. What is a mass? 5 kilogram. What is the specific heat given? This is CV 0.172. Next, change in temperature, 4 minus 0, that is 4. So you will get the answer in calories. That is dq is equal to 5 into 20 into 0.172 calories in joules. You have to multiply by 4. 1 calorie is 4.2 joules. So from this answer, you multiply by 4.2. You will get the answer in joules. The value is 14.4 joules. dq is equal to du plus dw. Here dw is 0. Therefore, du is equal to dq. That is 14.4 joules. Straight. Okay. This is another problem based on quantity of heat supplied to a system by thermodynamic process. Okay. Third one. The difference between two specific heats of a gas is 5000 joules per kilogram per Kelvin. The ratio of specific capacity is 1.6. Find the two specific heats. Cp and Cv you have to calculate. Given Cp minus Cv is equal to 5000 joules per kilogram per Kelvin. Next, Cp by Cv is equal to 1.6. Therefore, Cp is equal to 1.6 Cv implies 1.6 Cv minus Cv is equal to 5000. 0.6 Cv is equal to 5000. Cv is 5000 by 0.6. 5000 by 0.6 you have to calculate. What is the value? 8333.3 joules per kilogram per Kelvin. Cv have calculated. Substitute. Therefore, Cp minus 8333.3 is 5000. So Cp is 8333 plus 5000, 13333.3 joules per kilogram per Kelvin. Straight problem. Correct? Third one. Very good problem. A tire pumped to a pressure of 3.375 atmosphere and at 27 degrees Celsius suddenly burst. Calculate the temperature of escaping air. Given gamma is 1.5. Temperature T1. First of all, we should know suddenly burst means there is a change in temperature. What is the meaning? Change in temperature means it should be adiabatic process. System should be adiabatic. So PV power gamma is equal to constant. That only we have to calculate. PV power gamma is equal to constant. Okay. So T1 27 degree 273 plus 27 300 Kelvin. T2 you have to calculate. T2 to be calculated. Next, Pressure P1, 3.375 atmosphere. P2, suddenly burst means it comes to atmospheric air. That is not given. So atmospheric pressure, 1 atmosphere. P2 is 1 atmosphere. So system is adiabatic process. So adiabatic process means what is the equation? PV power gamma is equal to constant. P1 gamma minus 1 by equation T1 power gamma is equal to P2 gamma minus 1 by T2 power gamma. P1 gamma minus 1 by T1 gamma is equal to P2 gamma minus 1 by T2 power gamma. Now you equate. So when you equate, you will get T1 by T2 power gamma. T1 by T2 power gamma is equal to P1 by P2 power gamma minus 1. Okay. T1, what is the value of gamma? 1.5. So T1 by T2 power 1.5 is equal to P1 3.375 by 1 power 1.5 minus 1. So T1 by T2, 1.5 is 3 by 2. This is 3.375 power half. So T1 by T2 is equal to 3.375 power 1 by 3. Your aim is to calculate T2. So 300 by T2 is equal to 3.375 power 1 by 3. From this, you calculate T2. 300 by this value. Cube root of 3.375, you have to calculate. Okay. The final answer is 200 Kelvin. 200 Kelvin is what, man? Minus 73 degree. Because 0 degree Celsius is 273 Kelvin. Here we are getting the answer 200 Kelvin. So it should be minus 73 degrees Celsius. Okay. Excellent problem. So the tire suddenly burst. The temperature becomes minus 73 degrees Celsius. Now 51. Certain gas at atmospheric pressure is compressed adiabatically so that its volume becomes half of its original. Calculate the resulting pressure. Certain gas at atmospheric pressure is compressed adiabatic. Here, the condition given itself is adiabatic, so that its volume becomes half of its original volume. Calculate the resulting pressure. P1, 1 atmosphere. That is 1.013 into 10 power 5 Pascal. Then gamma is 1.4. Volume becomes half of its original value. Volume V2 becomes half of its original value. That is V1 by V1 by 2. So V1 by V2 is equal to 2. Given condition V1 by V2, that is V1 by half. That half means 2 will go to numerator. So it is 2. So formula PV power gamma is equal to constant. PV power gamma is equal to constant. This is the question. So what will I get? P2 is equal to P1 into condition V1 by V2 power gamma. P1 value given 1.013 into 10 power 5. V1 by V2 is 2.026 into 10 power 5 Pascal. Power gamma we missed out. So power 1.5. So I can write 1.013 into 10 power 5. 1.5 is 3 by 2. 2 cube, then root. So root 8. 2 root 2 you will get 2 power 3 by 2. 2 cube 8 power half. So 8 power half is root 8. Root 4 into root 2. So 2 root 2. Calculate this. You will get the answer. 2.694 into 10 power 5 Pascal. 2.694 into 10 power 5 Pascal. Correct? Straight problem. Sixth one. 200 centimeter cube of a gas is compressed to 100 centimeter cube at the atmospheric pressure 10 power 6 dyne per centimeter square. Find the resultant pressure if the change is slow and sudden. Change is slow means it should be isothermal process because temperature remains constant. Sudden change means temperature changes. So it should be adiabatic process. So for the first case, use isothermal process formula. Second case, use adiabatic formula. What is the equation? When the system is slow process. So it is isothermal. What do you have to calculate? Resultant pressure PV is equal to constant is adiabatic equation. So I can write P2 is equal to P1 V1 by V2. $200 centimeter cube is compressed to 100 centimeter cube at the atmospheric pressure. So atmospheric pressure is 1. This is 100. Previously it is 200 compressed to 100. So answer is what? 2. 2 atmosphere. No, there. I need the answer only in Pascal. 1 atmosphere is 1.013 into 10 power 5. 2 into 1.013 into 10 power 5. You will get the answer in Pascal. Simple. Second. Fast or sudden. So it should be adiabatic process. Adiabatic process is, just now we have seen previous problem, P2 is equal to P1 into V1 by V2 power gamma. Correct? Value 1 atmosphere, V1 by V2, 200 by 100. Gamma value given as 1.4. Gamma value 1.4. So 2 power 1.4. That calculation you have to do 1.4 log 2. Calculate log 2, multiply by 1.4, then take anti-log for that. because calculator will not be given in the exam. So you have to do only by logbook. So this one, please try it at home. 1.4 log 2. 1.4 log 2 is 0.3010. 1.4 into 0.3010 you multiply, resultant you find out and kill off. You will get the answer. 2.638 atmosphere. Correct? This is sixth problem. Seventh one. What is the efficiency of a Carnot engine working between ice point and steam point? What is called ice point? What is called steam point? Ice point means 0 degrees Celsius. Steam point means conversion of water to water vapor when it boils. That is 100 degrees Celsius. So 0 degrees Celsius ice point, 100 degrees Celsius steam. Carnot engine efficiency formula eta is equal to 1 minus T2 by T1. 1 minus T2. Always, from the theory of Carnot engine, T1 is a source temperature, high value. T2 is a sink temperature, low value. So, ice point, 273 Kelvin. Steam point, 100 degrees Celsius. That is 373 Kelvin. So, I can write 373 minus 273 by 373. Simplify. You will get the answer 0.268. That is 26.8%. So the efficiency of the heat engine between the two operating points, ice point and steam point, will be 26.8%. Okay, simple. Next, eighth one. In a heat engine, the temperature of source and sink are 500 Kelvin and 375 Kelvin. If the engine consumes 25 into 10 power 5 joules per cycle, find efficiency, work done per cycle, heat rejected to the sink. First, efficiency, eta, 1 minus T2 by T1. What is T2, ma? 375 Kelvin. T1, 500 Kelvin. Simplify, you will get 0.25. That is 25%. 25%. Simple. Straight. Second, work done. Actual formula eta is equal to work done by the system by heat energy taken from the source. Carnot engine efficiency formula. So work done will be eta into Q1. Eta is 0.25. What is Q1 energy given? 25 into 10 power 5 per cycle. 25 into 25, 625 into 10 power 3. 6.25 into 10 power 3 joules. Third, what is the temperature of the sink? Work done by the system, formula Q1 minus Q2. Heat energy by the sink. Q1 minus Q2 is equal to W. Q2 we have to calculate. So Q2 will be Q1 minus W. What is Q1? 25 into 10 power 5 minus 6.25 into 10 power 3. 0.06 into 10 power 5 I can write. 25 minus 0.0625. 25 minus 0.0625 you subtract. You will get the answer. It's not 25, it's 0.25. Q1 eta into Q1. 25 minus 6.25 into 10 power 5. 25 minus 6.25 you subtract, you will get the answer. 18.75 into 10 power 5. Correct? This is temperature or heat energy rejected to the sea. Heat energy taken from the source is Q1. That is 25 into 10 power 5. Heat energy rejected to the sink 18.75 into 10 power 5. Efficiency you have calculated, or they have 1 minus 375 by 500, that will be 25%. So major topics, related problems we have covered in thermodynamics chapter. Okay, thank you. We'll continue.